Good morning. This is Professor Grenfell's Math 12 Statistics course, and today we are continuing in Chapter 10, Section 1, and here we're going to be finally testing the significance of the linear correlation coefficient. So first, recall that the Greek symbol rho, that's how that is pronounced, looks like P, but sounds like R, rho. Okay, this is the population correlation coefficient. And essentially, when we perform the calculation, we compute the value of R, and that gives us a sense of how strong or weak the correlation is. But then what we're going to do is we're going to test the significance of it. And so that means we're going to make a conjecture about the whole population at large. So our hypotheses for this test, H subscript 0, is rho is just equal to 0. And so this means there is no correlation between X and Y. So if R is something not identically equal to 0, but if it is also not close enough to either +1 or -1, then we're going to not reject the null hypothesis, and we're going to say that the population correlation coefficient is 0. In other words, there's no correlation. That's what that means. And here the alternative hypothesis, H subscript 1, is going to be of the form of a two-tailed test. It is simply rho is not equal to 0. And so this means that there is a significant correlation between the two variables in this column. And so what this means is there is a strong correlation, or I should say significant, but that's too hard to spell. All right, so let's go into the hypothesis test itself. Well, the hypothesis test is just like every other hypothesis test that we have done. We'll go through the same exact 5 steps. If we're using the traditional method, we'll go through the same 5 steps as we would for the traditional method. We can also use the p-value method, but here this is a t-test. So the p-value method, we get a range, or unless we have a calculator to give us the, a more precise estimate for the p-value, we're going to kind of stick to the traditional method. And so the test statistic that we have to compute, like I said, it's going to be a t-test, so it's going to be a t-value is R times the square root of the whole quantity n minus 2, all divided by 1 minus r squared. And then the degrees of freedom are n minus 2 this time. And you can kind of remember this because there's in every sample item, in every item from our sample, there's 2 values for these 2 variables, x and y. And so that's why we're taking away 2 degrees of freedom. It's kind of one way you can think about it. All right, so we're going to quickly go through example 10-7. And this is located on beginning on page 557. And this says to test the significance of the correlation coefficient found in example 10-4. And remember, example 10-4 was to compute the correlation coefficient corresponding to the data from 10-1. So we're rehashing that whole thing. And they actually give us the significance level for the test. It's going to be the standard one, 0.05 for alpha. And they just go ahead and tell us what we had already done for computing the PPMC, or the correlation coefficient. And that right there is all we need. See the t statistic there, that only depends on R. So we only need one thing. Well, sorry, two things. It does depend on n as well. So we only need the sample size and the correlation coefficient. If we have to compute it by hand, yeah, it'll take a little while, but we've already done that by hand, so we don't have to go through all of that. So let's just simply perform the hypothesis test. Let's get ready here. There's our pertinent information. So step one, state the hypotheses. H subscript 0 is that rho is just equal to 0. There's no significant linear correlation between these two variables, x and y. And then the alternative conclusion, or sorry, the alternative hypothesis is that rho is not equal to 0. So the next thing we're going to do here is we're going to say here is a sketch of our t distribution. We have degrees of freedom, so that is one thing that reminds us that this is t, not z. The sample size here was 6, and so we have 6 minus 2, we have 4 degrees of freedom. And then we are using alpha equals 0.05, and it is a two-tailed test. So we would be in the same column as for a confidence interval with 95% confidence. Remember, that means our rejection region has 0.025 for the area over here, and similarly 0.025 for the area on that side. And we'll simply use table F to find the critical t values. So these are plus or minus 2.776. There's positive 2.776 and there's negative 2.776. So there is our critical region. We found the critical values, and I would say more importantly, we've shaded a little diagram there. Now, step 3, compute the t statistic. So we're going to substitute in. So we've got everything substituted in there. I didn't write down the original equation. I guess that's the one thing I forgot to do. So there it is. T is equal to r times the square root of the whole thing, n minus 2. So there's our sample size, and remember, n minus 2, that's our degrees of freedom. And then that is divided by 1 minus r squared inside the square root. So we have 0.982 substituted in here and here in place of r. And then the only other thing that went in was n, get n minus 2, simplify that to 4. So the test statistic that we get is 10.398. And you know, this is not even to scale, but this would be way over here on our t-axis. So in terms of this being a t-score, remember, things like this, t-scores, z-scores, that are in this range of 10, those are giant, those are off the charts. So step 4, make the decision, and since it's in the rejection region, we reject the null hypothesis, H subscript 0. So we've rejected the null hypothesis. And now recall, whenever we reject the null hypothesis, so there is the null hypothesis, H subscript 0, and to just symbolically show, I'll just cross it out. So I'm saying we rejected it. And then what does that mean for us? Well, the alternative hypothesis, that's literally what it is called, is H subscript 1. So that means basically we threw away H subscript 0, so we have to accept H subscript 1. Going back, what is RH subscript 1? Here it is. The alternative hypothesis, rho, it's not P, that's rho, Greek letter, is not equal to 0. But what does that mean in terms of the original problem, in terms of this question that we're trying to answer when we're performing this hypothesis test? Remember, saying that the population correlation coefficient is equal to 0 just means that there is no correlation between these variables. Saying that the population correlation coefficient is not equal to 0 indicates that there is linear correlation between these two variables. And so we summarize the results of this hypothesis test as follows. We say there is significant linear correlation between the number of cars a rental agency owns, and I just said that that was X, just to remind us, and its income. So that was Y. Now, just here's the important thing. Do not just say there's a significant relation between X and Y. Say what those X and Y are in the original problem. And then also, don't just say rho is not equal to 0. You can't leave it as that, because that does not say anything. So remember, we have to use words first and foremost, and also we have to use the words of the original problem.